Um, okay, so tēnā koutou kua hui hui mai nei, e mihi ana ki ngā mana whenua, ko Donna toko ingoa, no te arawa ahau, e mahi ana o hei kaiako, ki Kristen Kura, no reira, tēnā koutou katoa. So I won't dwell too long about who I am, but if you haven't met me before, my name is Donna Golightly. I have been teaching for a very long time and am currently teaching at Kristen School. I teach a Year 6 class and I lead our digital innovation in our junior school. So Kristen is made up of 3 schools on the one campus, and I work with the kindy to our Year 6 teachers. So what we're going to focus on this morning, let me just pop this up here. That's better than you can see. So we're going to focus on how we can encourage our learners to see maths beyond a series of numbers. We're going to look at some digital tools to engage in some authentic maths tasks, and we're just going to touch a little bit on AI because it is here to stay and it isn't going away. So where might it fit in our maths program? But firstly, so why would we think about using digital technologies in our maths program? And I know the common practice model may not exist for much longer in the way that it is at the moment, but it is existing at the moment. And so within that common practice model is a statement that says that we should use technology to support our ākonga to communicate maths, to make meaning using multiple representations, and to compare, contrast, and critique. So we're looking at how we can use those maths tools in a higher order thinking rather than just for consumption or skill and drill, which is where we tend to see it happening. So just before we start, if you can just drop in the chat, and Robin, you might just want to let me know where the majority is. What age students do you work with so that we can make sure that we, or that I am pitching this to the right level? There's no point in talking about what you can do in a secondary class if we've got a lot of primary teachers, or if we have some middle school, senior school teachers, they don't want to know what we can do with 5-year-olds. So maybe just drop in the chat what level you work with, and we can I can make sure that I give some ideas for across the board. So what are we seeing, Robin, in the chat? Kind of a mix, or? Oops, you're on mute, Robin.
There we go, best place for me on mute. So we've got year 8, year 2, 1 to 8, 5 to 8, 7, okay. 1, 9 to 13, 9 to 13, 5 to 8. So a little bit of a mixture.
A little bit of the mix. Awesome. So we'll go across the board.
7 to 10, yeah.
I'm just going to see if I can get rid of, sorry, I'm just going to see if I can get rid of that in the corner, this remote for slides. I push that away. There we go. Okay, so we'll kind of go across the board. So in my maths classes at school, when I'm working with my kids, I don't call it a warm-up with the kids. We just call it getting our maths thinking brain started. So we're going to get our brain into thinking about our maths. But that was too long a sentence to put on the slide. So we do a lot of what do you notice, what do you wonder? Put up lots of different things. We talk about the maths that we can see. We talk about the patterns that we can see. But one of the things that I also do is I use PO, which is linked. So if you have access to the slides, you might want to click on that and have a look now or have a little play later. But PO is accumulation. So it's a collection of different AI sites. And it has a really cool coloring generator that you can create coloring images. So I'll often create my own kind of like coloring in image and give it a personalized topic for what the students are doing. And then we'll do what do we notice, what do we wonder? And sometimes when we're doing a bit of mindfulness, we are a one-to-one iPad school. And so I try not to print things out, mostly just to save some trees. But also what I do is I just airdrop the photo to the kids, and then they do some mindful coloring when we're reading a story or something later in the day. And it kind of keeps that maths thinking at the front of their brain at other times of the day as well. So that's just a little idea that you might want to use. But also I know Canva now has a coloring generator within it too. So just thinking of ways that we can kind of change up what we're doing with our digital tools in a way that's going to make it a little bit more engaging for our kids. Robin, as we go through, if anyone has a question, just feel free to interrupt me and throw the question in.
I'll just keep an eye on the chat. I've dropped the slide link in.
Thank you. But one thing I did want to reinforce before we start is that pedagogy has to be first. So often, if we're thinking from a pedagogy first lens, then it might not be relevant to use digital technology. So I am kind of framing what we look at today with the thought in mind that we've already done that pedagogical breakdown of what we want to teach, how we want to teach it, why we're teaching it. And we've gone through the questions about whether digital technology is going to add value. And we've answered yes in some way. And so then we're going to go forward and use digital technologies. But often the answer is no, it doesn't add value. I've linked this document. It's an oldie but a goodie, Effective Pedagogy in Mathematics. If you haven't seen it, if you click on the image, it will take you to a PDF. And it just goes through some really awesome thought processes about what good pedagogy in mathematics looks like. And I always throw this in just because I love it. When we're thinking about making a change in our practice, whether it's in our mathematics practice, whether it's in how we use digital technologies, whether it's in our literacy practice, whether it's just in our teaching practice full stop, it's always good to come back and think, if I'm feeling a little bit anxious about it, if I'm a bit confused, then I can come across here and go, well, if I'm confused, maybe I'm missing the vision. Maybe I don't understand why I'm being asked to do this or why it's important to do this. So then I know that I need to go and investigate more about the vision to help me unpack my confusion. Or if I'm feeling a bit anxious, and I spent 4 years as a digital learning facilitator in schools, helping with digital technologies. And a lot of teachers were feeling very anxious about the use of digital technologies, especially in the mathematics program. And I found that what they were missing were the skills. They didn't know how to use the tools. And because they didn't know how to use the tools, they were anxious about using them, because what if something went wrong? Or what if I can't use it? Or what if it doesn't do what I'm thinking it's going to do? And my best advice with that is just to go for it, because the kids will learn. The kids love being the ones to solve the problems. And I still have kids coming up to me and going, oh, hey, Mrs. Golightly, I found out how to do this. Look, it does this. And I go, oh, I didn't know it could do that. That's fantastic. And then they teach someone else. But just coming back to acknowledging that teaching is a tough profession and there's so much that we have to do. So if we're feeling a certain emotion, that's 100% okay. But we can also have something to hang our hat on and go, well, how do I address that? So I love this. Comes from Mel Robbins. And if anyone listens to her podcast, fantastic. And as Robin said, I'm currently doing a Kalman Fellowship and at Auckland University with Lisa Darrett. If you ever get the opportunity to do her course, fantastic. It's around leading curriculum change in mathematics. And you're able to identify your own problem of practice and then do some research into it. So for me, of course, I'm looking at how digital technologies are used in maths. And I came across this from Catherine Attard, who is an Australian researcher, and she's come up with this framework for education, for engagement with maths, because often teachers will say, oh, the iPad is far more engaging for the students, or if they're on their Chromebook, they're far more engaged. Well, what does that engagement actually look like? What are we basing that statement on? And what are we using to qualify that statement and say, well, I know they're engaged because they have this, and this type behavior. And this framework has actually made me stand back and look at my own practice. And she talks about the 3 types of engagement. So cognitively, they're engaged in understanding what the task is about. They're engaged in group discussions and the social side of it. And they're also engaged in the value of learning and wanting to know more. And then she goes on to break that down and say, well, this is what we need to think about in terms of creating an engaging mathematical program. So that might be something that you want to delve into a little bit deeper and just think about, when you do say your students are engaged, what does that actually look like? And of course, Joe Bowler stuff, I'm going to go through this quite quickly because there's a lot of stuff to get through. I also kind of want to put the caveat out there that we're not going to cover everything in these slides today, but I deliberately left it in so that you can go back and explore later on. But if you're looking at building a mathematical mindset, which is something we do at the start of every year, then these Joe Bowler's resources are really fantastic. All the images are linked and it'll take you just straight to the resource. She has these great rubrics that you can kind of just go through and ask yourself, am I really using open tasks? Am I getting my kids to think about explaining their reasons? Am I focusing on depth over speed? And there's about 4 or 5 of these that you can go through. In my reading for my university course this year, I also came across this, which I thought I'd never seen before, and I don't know why I've never seen it. It's a mathematical model of TPAC. So if you've not come across TPAC before, it's a way of understanding what we as a teacher need to do to use our digital technologies effectively. We need to understand the content of our curriculum. We need to understand our pedagogy. How are we going to teach that content in an effective way? And we need to understand how the technology works and how the technology supports our teaching of the content. And the intersection of all of that thinking is TPAC. My one problem I have with TPAC is it puts the T first, which insinuates to people that technology comes first. I'm thinking how I could reframe it with the T at the end, because actually the technology should be the last thing. We should be our pedagogy, our content knowledge, and then technology. But this model, and again, this image is linked for you, talks about in a mathematical scenario, how do we move teachers who have got some content knowledge and got their pedagogy and the technology is their next step? So how do we move them from not having a good understanding to this intersection? And Ness, Sadri, and Lee have realized that when they observed lots and lots and lots of teachers, they were able to break it down into 5 common things that teachers went through to go from not understanding the technology to being at this intersection. And I won't go through them all now because we don't have time. But if it's something that is of interest to you and you want to explore that a little bit further, click on this link here and it will explain each of those steps for you. And again, the SAMR model, so if I am using a digital tool, how do I know that I'm adding value? So this is a model that's used widely across schools. I find it a little bit tricky in that it can be quite subjective in terms of whether you think something is just substitution or whether it is actually augmentation, but it is a good framework to just make you stop and think, am I just substituting what I could do on paper with technology? Or am I adding a functional improvement? Or am I changing the task significantly? Or am I creating a task that could not have been done without the technology? And when I was researching, there's some questions there that you can ask yourself. But I came across this, which I thought was really awesome from a school in the States, where they took that TPAC model, they took that SAMR model, and then they created their own model for their school, which I think is fantastic because that's what we want to be doing. We want to be personalizing it for ourselves the same way that we do for our students. So I love the way that they thought about, if I use technology, how is it going to help the student? And so these are the different things that it could help the student do. But also, what is the educator doing with the help? So how is it helping me as a teacher? And then also, what is the technology itself actually doing? Is it allowing them to interact with people outside the walls of your school? Is it allowing them to collect data that they wouldn't be able to collect otherwise? So I thought that was a really lovely way of thinking of it. How is it helping the student? How is it helping me as a teacher? And what is the technology actually providing for the student to be able to do? So whatever you use, I just really love to think that we stop and use something, some thought process that works for us that helps us decide the value of the technology that we use. And of course, in our refreshed curriculum, which we know is being refreshed, we have the do's. And I think this is where we need to look at our technology. So not necessarily in what skill can the technology help my students with, but which of these dispositions can it help strengthen? Is it going to help them explore more? Is it going to help them explain their thinking more clearly? So the do's are a good place to come to think, is the technology adding value here as well? So one thing that we have been focusing on, we're a PYP school, which is the primary years program of the International Baccalaureate. And what we've been doing this year is working with our students about what will they learn and how will they do it. So we try to bring in those dispositions alongside their content knowledge. And if you're familiar with Kath Murdoch's work, then you may have read about her split screen teaching technique, where on one side you have the actual task, what are they learning? And on the other side, you have how will they learn it? What thinking skills do they need to use? So for us as a PYP school, we have 10 learner profile attributes, and we have some approaches to learning. And so we draw from those. But the key competencies in the New Zealand curriculum are a perfect place to draw from as well. So when we give our students a task, we're giving them that split screen. We're saying, this is what you're going to learn. And while you're learning it, you're going to be using your thinking skills, and you're going to be communicators. And so you can see here, often putting a visual symbol next to what you are presenting to your students helps the students, for some students, to remove that cognitive load of all the reading. And they just see this. I use this all the time. So every time I use thinking skills, I use the same icon. And I just used Ideogram, which is an AI generative website. It's free and paid, but the free version lets you create, I think, 20 images per day. And it's the generative AI site that handles words the best that I've come across so far. A lot of sites, if you put a word in, you'll get the word, but it will have crazy spelling. Whereas Ideogram's spelling is the best I've come across. And Bard, which is now Gemini, wrote the fraction question. So if I click on the image, I'll just pop out and quickly show you what it looked like for our students. So we gave them their task. This is what they were doing. And then we scaffolded it. So what's the evidence of their maths brainstorm? So they were doing it on paper. They weren't working digitally, but they were uploading the evidence digitally. Now for my students, the thinking skills we used, what do we do to use our thinking skills? What do we do to use our communication skills? They use voice to text a lot. I've got some students who struggle with processing, some students who struggle with the physical act of writing. And so for them to be able to voice their reasoning takes away, again, some of that cognitive load and lets them just focus on their thinking. And so being able to record it digitally is an advantage because they can use speech to text, which they use a lot. And then they had to think about their most reliable option. There's scaffolds for them to just click and it drops the image in. So they're not having to worry about resizing their image, or, they kind of tend to get in the middle and they skew the photo. And so that scaffolding takes away the playing around with the digital, kind of making it look pretty, and they can just focus on their math thinking. And then we used to think, now we think. So they have some kind of reflection thing at the end. So just thinking about how you're going to frame the scaffolding for them can be a really good help with digital. Something I really advocate is start with the tools you already have, or start with what your students are familiar with. There are so many tools out there that it's overwhelming. Even I find it overwhelming sometimes. And I go down rabbit holes, and I sort of after about 20 minutes down a rabbit hole, I have to talk to myself sternly and tell myself to stop. I don't need this rabbit hole. I don't need this new tool. I have enough tools to deal with. Few is better, especially for your students. Throwing a whole lot of things at them is just going to be confusing. I'm a great believer in use less, but use them well. So think about what you've already got. Everyone has a camera, whether you have it on a Chromebook, whether you have it on a laptop, whether you have it on an iPad. Admittedly, the iPad camera is much easier to use to walk around with, but everyone has a camera. So thinking about how you might start using the camera. And so what I've done is I've gone through and just put some quick activities, but also gone through, put the SAMR model at the top. So this is linked, the activity here is linked, and some of them just have the activity described. But if you were going to use this in your classroom, I really encourage you to think, where would this fit on the SAMR model? Is it straight substitution? Am I just using a digital worksheet? I could print it out. They could have it on paper. It's no different. Or am I adding a functional improvement? And no, I'm not going to reply to Google right now. And so I've just thrown some ideas in there, all just different ideas of how you could use the camera, taking photographs of each other's shoes and their hair color and making a graph, right from the young students up to, this is for much older students. Just different ways that you can think about using the camera. And I'm sure that you've probably got lots of other ideas as well, but start with what you've already got. I talked about scaffolding a little minute ago with our split screening. But I think one thing with Google Slides is I tend to see slides by death, and they are all 16 by 9. Just remember that Google Slides doesn't have to be landscape 16 by 9. You can change the size of a Google slide and make it any size you want. You just go into File, go into Page Setup, click Custom, and then click centimeters. You've got to change the measurement first. And then you do 21 by 29.7, and that makes it A4. I've seen a lot of teachers create resources on a Google slide, and then they print it and they go, oh, it's so annoying, it doesn't print properly. If you reverse those digits, those numbers, and you make it 29.7 by 21, you're going to have a landscape piece of paper, and then it's going to print properly on either A4 portrait or landscape. So just kind of think about what is the purpose. Again, this is linked for you, so you can have a look at that. But also, if you are a Google school, Google Workspace school, and I hope you've got the upgraded version, so you know the Ministry of Education will fund the license for every Google school to have the Learning Plus edition, which gives you a whole lot of more great features, that you use Mote. So Mote is a Chrome extension, but it allows your students to voice record on Google Docs, on Google Slides, and Google Sheets, whatever you're doing, so the students can still explain their thinking. They can just click on the Mote button, it records their voice. I think the free version lets you have maybe 30 seconds of recording, and the paid version lets you have a lot longer. So just thinking about, okay, I'm using a Google tool, but I don't have to have it the size that it is. This is just an example of a younger student. I won't go into all the examples now, but it just has a poem. And then I've used Mote to record myself reading the poem, so that for younger students, it takes away that cognitive load. They can look at the words and hear you say it. And then they can also record their thinking back. And for older students, again, change the size of the slide. Think of what is relevant to what you're doing at the moment. So this was an Anzac Day one that we did. What they have to do is choose an addition sum, could be subtraction, could be multiplication, could be a combination, to make a certain number. So this was they had to equal 48. So they have to write their sum in here, what's going to equal 48, and then they delete whatever numbers they put in here, they delete them. So they just come in, whoops, click on the end there, sorry, click on, get the crosshairs, delete. Okay, does that give me a clue to what's underneath? No, it doesn't. So what's my next one? Maybe it was 7. And I'm going to go with this 7. Oh my goodness. This 7. And they just delete until they can guess what the image is. If they've done all their numbers and they can't guess, they have to write another sum that equals 48 with the numbers that are left. And then they can delete those. And then they write a picture. My picture is of what? And the clues are used. And if they delete the wrong one, it's a great teaching moment for technology. Command Z puts it back again. So Command Z puts it back again. So again, you've got that perfect moment to introduce the technology alongside the task, but in a purposeful way. So just think about what little skills you might be able to throw in as well. Videos are a great way of, I wanted to say engaging students, but getting students to use their higher order thinking. So again, you can do this in PowerPoint, you can do this in Keynote, you can do this in Google Slides. So whatever your platform is, you can do the same thing. You put your video in. Once it's in a slide, you don't get the advertising as well, which is really cool. You can start your video and stop your video at whatever time you want. So when you click on the video, you get video playback options. They don't have to watch the whole video. So this one here, what they've done is they've got to solve the passcode. So they have the problem. But if I click on the video and I open format options and I click on video playback, then once it loads, you'll notice that it stops at 2 minutes 20. And so it gives them the problem, but it doesn't give them the answer. So then they go away and they work out what the problem is. And they can either take a photo of their maths book and upload it, or they can use the audio recording tool. This is the Mote recorder here. And then they watch the solution. So the solution, you'll notice here, starts at 2 minutes 27 and goes to the end. So you can actually chunk the videos. You can do that in Edpuzzle, does the same. And if you are one of those schools that has the upgraded Google Workspace, then you can now do the same thing with videos inside Google Classroom. So if you're a Google Classroom user, you can upload a video and you can stop it at certain parts and put your questions in. I've done a lot of talking. Robin, are there any questions come up?
Not a single question yet. I think we're all down the rabbit hole.
Yeah. Yeah.
Thinking about possibilities. I know I am.
Yeah. One of the things that Catherine Attard talked about in her framework for engaging mathematics was student choice, students having choice over their learning. And so whatever platform you're using, creating a choice option for your students is a great use of your technology. So this was one we used when we were doing subtraction. So what are the 3 big goals that we're working on? And then the students have a choice right from the start. So they can go, well, actually, I'm really good at using standard place value, but I'm not so good at reversing. So then we just click on it and it takes me to slide 6, which is where those tasks begin. Because within slides, we can link between our slides. And so I can send them, I can go straight to slide 6. And there's a video there that talks me through it. So I can scaffold again the learning. They don't need me. They can watch the video. I do find that a lot of my students at the start of the year think that videos are for entertainment. So we do spend a lot of time in term 1 talking and practicing learning from video so that they understand that there is more than one thing that we can do with a video. Excuse me. And so they can watch the video and then they have a choice of activities to practice that concept. And again, there's activities from a book if they like to work from a textbook, as some students do. They can do that and they can do it in their textbook, in their math book, or they can do a game, or they can do some problems, or they can have figure it out. They can do some figure it outs. So again, just scaffolding what it is that they want, that their choice, they get to choose. This Connect 4 game was very popular with my students, so we made it in Keynote. And if they got the right answer, it has conditional formatting on it. So if they put the right answer in, the cell turns a different color, and straight away they get that feedback, whether they were right or wrong. But lots of different ways that you can just give students that choice. It's really important. So here's our Connect 4 game. So what we did was they each had their Connect 4. They shared, one person made a copy of it. They shared it with their buddy. So they're both working on the same file. That in itself is a learning curve for a lot of students. Understanding the difference between being on their own file and being on a shared file with other people is something that needs explicit teaching. So at the start of the year, we do a lot of work. I used FigJam this year because Jamboard is going away. So I thought I'd try FigJam as an alternative. And FigJam has a really cool plugin where it's a Polaroid camera. And it looks like a Polaroid camera. And it spits out a photo like a Polaroid camera. And I thought, oh, this is going to be great. This is going to be a great activity to start the year. So I made one FigJam file. I had 25 squares. I wrote name at the top of each square. And I showed the kids how I could click on this Polaroid camera. It would take a photo of me. I could put it in my square and write something about myself. And because we were all on the same file, we could learn about each other. Oh my Lord, it was disaster. We had 25 Polaroid cameras. Kids were just duplicating camera. We had very silly Polaroid photos being taken. We had people deleting other people's photos. We had people writing on top of other people. And it was just, I could see my learning assistant at the back of the room just rolling her eyes. So we stopped. And instead of me saying, hey guys, this is terrible, I said, what is happening? And we actually talked about what was happening. And it was a fantastic teaching moment about being on a shared file. And then we tried again the next week, and it was a bit better. I won't say it was perfect. Then we tried again the following week, and we got the idea. So actually explicitly teaching, finding ways that you can get students to practice those digital skills that they may not have done before is really important. And so what they did was they opened the board. There's all these different subtractions, which I'd purposely created because I knew that was the stage that they were at. So the questions fitted what they needed to learn. And you can totally just change the game and put your own questions in there. And because we have some place value equipment, but we didn't have enough, we used Mathagon. Now, if you've not seen Mathagon before, I didn't link it. I've linked it further along. If you've not seen Mathagon before, it is one of the best digital manipulative tools that you can use. It has Numicon blocks, it has place value blocks, it has spinners, it has dice, it has all sorts of things in it. And we'll have a little look at that later on. But they had Mathagon open. So one person had the game open, one person had Mathagon open. And if they needed to practice actually making that number with place value blocks, and the physical blocks were all being used, they could use Mathagon. So we had a mix of physical manipulatives, but also digital as a backup when we needed some more. Maths Reps, this is just linked for you. You can click on this and it will take you to the Maths Reps site. They have a whole heap of Google Slides already formatted like this one here at different levels. Right from, I think, grade 2, it's American. So grade 2 would be about our year 3, right up to equivalent of our secondary level. And you can just bring it up as the starter of the day, as a quick warm-up, as a repetition, as a get to know your number. There's just a whole lot of them there. And I'm a great believer in don't reinvent the wheel. If somebody's already created it and you can make a copy and tweak it to suit you, go for it, because teaching is busy enough. A lot of people have Google Sheets and overlook Google Sheets. It is fantastic for mathematics. Excel, if you're a Microsoft school, Numbers, if you're an Apple school. So again, you can do it on any platform. Great for statistics, there's an example linked there, but also the way that I've been using it with my students is pixel art. So a great warm-up. And when they put the correct answer in, if I open this one for you, you put the correct answer in, and it's formatted. So this is user template. So I use this link a lot. I know a lot of people use the make a copy link, but when you do make a copy, you get a white screen and it says, do you want to make a copy of? But you actually don't know what's behind that screen. 99.9% of the time, it's going to be what you think it is. But there's also an option that it's not what you think it is. So when you use the user template, it means that people can actually see what it is before they make that copy. So I always use the template rather than the make a copy. And then I can see what it is that I'm making my own copy of. So this is it here. So we put the answer in here. I think it's completely loaded. So if I put 8, then part of the picture appears. If I put 40, more of the picture appears. So as they go through, again, they're getting that immediate feedback. You as the teacher, you don't have to mark this. And you can just go through and it will ultimately make a picture. So what I have done is on this slide here, these are not all mine. There is a Facebook group called, I think it's Pixel Maths for Teachers or something. And there's teachers all around the world who are creating these pixel art math activities, who are happy to share them, happy for people to make a copy. So the ones that people have been happy to share, I've made a copy and put in a folder. And if it's something that you want to explore, then click on this image, it will take you to that folder, and you can explore that with your students. And again, younger students, a lot of teachers say, can't use sheets, my kids are only 5. There's a woman called Christina Pinto in America who does some amazing maths with young students. And this uses Google Drawings. So you can put a drawing on top of a sheet, and then you drag the leaves and you put them on, and then the students tell you how many they are. They put leaves up here, and it's a really lovely beginning data statistics activity. So sheets can be used at all levels. Just some more examples of sheets, Google Sheets version and numbers version, where they put the right answer in and the next question appears. So often, if you put the answer here, the next question will appear here. Often the kids will race ahead and not really know whether they're correct or not. So if they put the answer in here and the next question doesn't appear, their answer is wrong. So they have to go back and work out the right answer before they can get the next one, before they get the next question. Again, adding value, it's marking it for you automatically. The kids are getting feedback automatically. And you can make those questions completely personal to what your students need. So thinking about AI, so Peer Deck, if you've never used Peer Deck before, it's a free and a paid, but within the free version of Peer Deck is this tool called Flashcard Factory. And vocabulary is something that we often overlook in our mathematics program. And as a school this year, we're making a much more concerted effort to focus on vocabulary. And what Peer Deck does is it lets you create your vocabulary list, and the AI will automatically give it a definition. If you don't like that definition, go in and change it and make it what you want it to be. Then you share it, you open it up, the kids jump in just with a code, and it automatically puts them in 2 teams. And what they have to do is they have to write the definition of the word, and they have to draw it, and then it goes into the truck. At the end, they get to vote. So each team is doing the same vocabulary list. And at the end, they look at each other's, and as a class, they can decide which is the more accurate description or which is the more in-depth definition. And so it's just really awesome, but in a collaborative way, because they have to work with their partner. It automatically puts them with buddies, and they can't choose their own partner. And so it's great for mixing up those students and getting them to work with other people. So the image is linked for you and it will take you to an example. Book Creator is another amazing tool that has everything in it. Voice to text, drawing, video, 3D, you name it, you can do it in Book Creator. And so there are 2 examples of Book Creator and how you might use it in your maths program. So we created a maths vocabulary book for our students, and it pushes out a copy to each student, and they can go through and practice their maths vocabulary. We also did a times table one, and you can make your own copies of these books. So if I click on the times table one, it opens up like this. And if you remix the book, you get your own copy of the book, and then you can push that copy out to students. So it just has lots of different ways that they can practice their basic facts, but they have to take ownership. So what did they practice? So with Prototech, did they practice stage 5? Did they practice 8 times tables? What did they practice? How well did they do? What's their next step? So getting them to think about their learning at the same time. So lots of different ways that they can practice it, times table songs, activities they can do. And you can, if you make your own copy, you can edit it, put your own things in there. So just lots of activities and ways that they can practice their times tables. And so what we do is we have 1 maths period per week. They go into their Book Creator times table book, they choose an activity and they practice their times tables. It just is a different way of doing it. This is another really awesome site if you haven't seen it, Math Learning Centre. Again, it has great manipulatives, fraction boards, geo boards, timelines, number lines, tangrams. And if you click on this here, there are some ready-made activities to get you started, so you don't have to reinvent the wheel. These ones have an app for the iPad, and they're also web-based. I just recommend using the web-based. If you use the app-based, it's going to take space in your hard drive, which you don't need to take up. And it works perfectly well on the web if you're on an iPad. So you can see down here, there are the options. If you're on a Chromebook, you might want to install a web app, but again, it's going to take up space. So I just always go with the web app, and then it opens up for you. And it looks like this, and you can just put your rubber bands on and they can create. You come down to the board here and you can have different size boards. But the really awesome thing about these tools is the toolbar is the same in everyone. So when they learn how to use the toolbar, it's the same across all the tools. There's an I button on every single one that tells them how to use it. So they can just learn how to use it. And I think, yeah, the done is under there. And then the share button. is the same on all of them. And now you can save them as an image. So the students save their image, they upload it to their Google slide, wherever you want them to upload it. But you can also create an activity. And if you copy the link and push that link to the students, they get it with the activity that you've already created on it. So really useful, helpful set of manipulatives if you haven't explored them. And Methagon now is owned by Amplify, which is part of Desmos. So it's moved into Desmos. But you can see down here, these are all the different things it has. It has the shapes, it has tangrams, it has whatever you want. You just click on it to open it, click on it to close it. Numbers, it's got number bars, so our old Cuisenaire rods, it's got number tiles, and you just literally pull them out. What I love about, if I come down to fractions and fraction bars, I'm just going to delete that one. You pull out the fraction bar, just pull out fifths. You notice down here you can split them. And so now we can move them as single pieces. We can merge them. But this is amazing. So this is play. And so now a lot of them have like a musical note behind them. Oops, stop. Stop. If you click on the three dots, you can change the scales. And if you open the music, you can actually click and change the type of music. So I had my linked in the notes as a really cool fraction activity, but they had to make a song at the same time. And one of my boys, who was right into music, loved it. It absorbed him for weeks. He carried on doing it in his own time. So if you didn't explore anything else, Methagon might be a great takeaway. And here's the fraction activity that they did. So you can explore that and have a look. Whoops. We don't want to hear what he created though. Just a couple of other slides you can jump into that talk more about how to use those two apps. So then this is Desmos. So if you haven't explored Desmos, if you teach upper grades, really, really awesome. If you teach lower grades, equally as awesome, caters for everyone. It now has in its free version, these featured collections. And so you can filter by grade down here. There are ready-made to go starter activities, lesson activities that you can explore that use Methagon and the Polypad. Again, don't reinvent the wheel. It's all there for you. And just really quickly, there's just some resources here that you can go through. Assemble. Somebody is assembling a whole lot of great maths activities all in one place. So again, if you haven't used that, I use it as starters, and this is an example of one of the starters. And we were doing a what do we notice, what do we wonder? And this was a good 15 minutes of what did they notice, what did they wonder, which was fantastic for their maths thinking. And then just some other tools. I'm just going to whip through. Every time I do that, it wants to play to AI, because we've got about 4 minutes left. And I just wanted to touch on some AI things that you can use. You can go through and look at these resources later. School AI has a maths tutor built into it. So a lot of these AI tools now are allowing you to create, they're calling them spaces, but it's essentially a chatbot. And so somebody has created this math tutor chatbot. And so you go in and you ask it a question, and it asks you more questions. So it encourages you to think deeper about your mathematical thinking. So if you're thinking, how is AI going to be helpful for me for math with my students, this might be something that you want to have a look. If you just want to think, how can AI help me as a teacher, then these two sites might be helpful. Magic School, I know lots of teachers are talking about Magic School. It used to be free, it's now paid, but there's still a free version. But you can create your own math word problems, and you can create a spiral review generator. So they do have a couple of math-specific tools in there, as does this Teach Tools AI. Again, free and paid, and the free lets you have 5 per month. I think with AI, it's always going to start free because they want to hook you in, and then it's going to go paid. So it's really important to think about, what is the purpose of AI? What do I actually want it to do? I don't pay for any AI because I use Canva or I use Gemini, and I can do everything I need to do with those two tools. But inside Canva, they have now also started a lesson bank. And inside that lesson bank, there are a whole lot of maths lessons, but you also have this AI image generator where I've got my students to create fraction sets. So rather than just pulling out elements of their own, they've had to create an image that reflects themselves somehow and then make a fraction set from that. So there's just a few different AI things in here that you can do. And then just at the end, there's just some sites that can be helpful for you. So that's it, Robin. That's a lot of talking.
Wow.
But if you want to get in touch, happy for you to email me or connect with me, ask the question on Twitter. Always happy to help and always happy to answer any questions.